Hello everybody! Welcome to Ask Math Anything. I've just realized that I'm standing in a different place than usual, and that's because we were just using our camera to record other things. Actually, now you can even see my microphone. If you don't mind, I'm going to adjust the angle of this a little bit. We're doing some geometry now. Let's do some applied geometry. So I'm just going to move the angle of this camera and I'll be right back. Okay. Yes. Hi, microphone. Let's see if that did anything. Am I in the right place? Yes, I think it's all good. So, wonderful. Well, in that case, I want to first welcome everybody. Welcome to Ask Math Anything. And what we do here is that we have a session where anyone can ask any kind of question that they want, and I'll attempt to answer it. Now, the kinds of questions that people ask are usually questions that range through math and maybe some applications of math. But I try to pick the ones that I can say something about where my explanation will make sense if you're learning algebra or geometry. But of course, you'll see that the questions sometimes go quite far afield. I'll try my best not to get fooled. Some people here like to ask questions that look easy but are really hard. We'll see what happens. All right, let's go ahead and start. What kind of questions do we have today? Wow, so many. Wow, so many to choose from. So I'm trying to see. Oh, okay, let's start with something random by Lee Random. They say that 1 plus 1 equals 11. But when is this actually true? 5 cases. Really? 1 plus 1 equals 11? I'm not sure. So I think the only thing I can say here is I was at first trying to guess, is it a different base that you're talking about? Because sometimes you could say I work in a different base, and if I work in a different base, the answer should be 2, but unfortunately there's not another base that you can use. When it's base 2, you know how you write 2? 2 in base 2, so we often write 2 if it's a base 10 number. In base 2, oh my gosh, this is really cool. I never thought of that before. Look, 2 in base 10 is 1, 0 in base 2. Mind blown. I actually didn't know that you could just flip them. This is the first time I ever saw something like this. But anyway, this is what base 2 means. It's like this is how much 1s there are, this is how much 2s there are. And unfortunately, base 2 won't work. In base 2, this is 3. So if I was going to go and say, under what conditions is this true, maybe I'll just go and say if you're using Roman numerals, maybe that would work. So if you happen to be Roman, I think that's okay. But I'm not sure what other things there might be. So at first I thought this would be a base problem, but I think I'll just go and say Roman numerals. That seems like that's a reasonable case. All right, let's do more questions. I want to see what kind of range we can have here. Oh, okay. So here's a question. Yaduraj Chowdhury says, a subset B of the integers from 1 to 100 has the property that no two elements of B sum to 125. Okay, so we have some subset B. B is a subset of the numbers 1, 2, up until 100. Subset just means it's some of those numbers, maybe all, except that there's a rule. The rule says that no two numbers add up to 125. Now, if no two add up to 125, the question is, what's the most number of numbers that could be in the set B? What's the maximum number? Well, let's just call it what's the maximum size of B? Well, when you look at a question like this, at first I try to understand what the question is talking about. No two numbers add to 125. So how could I get two numbers add to 125? I guess one way is if I have, if I have two numbers adding up to 125. But what I mean is that there are certain pairs. It's basically that you can go and take the pairs of numbers that add to 125, and in each pair you can only take one of them. Let's see what we can do there. So for example, what's a pair of numbers that adds up to 125? A pair of numbers that adds up to 125, half of that is 62. Is that right? 62 plus 63. Is that 125? I was trying to divide 125 by 2 in my head. I think this works. 125. Yeah. That's 125. So once you look at this, you say, now you can only take one of these two. Oh, okay. So now I just need to see how this all pairs up, because I can also make a pair 61 plus 64. That's 125. I see people doing this already in the chat. And if I just keep going, it goes all the way down to 1 plus 124, right? We have to be careful. This is not useful because there's no 124. So don't stop at this 1 plus 124. 124 is not in this set, so you can't do this. This is not right. Instead, what we need to do is we need to say, what's the last one we'll get? The last one we'll get is 100. So the last one we'll get is 100, and that's what you have with 25 plus 100. Now what we know is that from each of these, I can only take one, and then everything else I can take, because anything else won't add up to 125. So from each of these, only take one from each line. Okay, then what's the answer? So the answer is just going to be how many lines there are plus how many more numbers there are. That's one way to do it. But there's a better way to do it. The better way to do it is to say, how about instead of saying only take one from each line, that's the same as you must get rid of one from each line, and we'll say the answer is 100 minus how many lines. So this is in fact the same as get rid of one from each line. And now if I get rid of one from each line, let's just see how many lines there are and take 100 minus that. Okay, so how many lines are there? Well, if I have 62 here and 25 there, I should just do 62 minus 25, right? Is that right? Is that the number of lines? Just 62 minus 25? No, you have to be careful of the endpoints. There's a plus 1. 62 minus 25 is like the number of hops I take, but the number of hops I take is one less than the number of rows that there are. So the number of lines is equal to 62 minus 25 and then plus a 1. Okay, what is this? Now we have to actually do some arithmetic, which is what I'm very bad at. So I will take 62 minus 25. 12 minus 5 is 7. 5 minus 2 is 3. Is that right? I always take a step back and look at it, and I see if I add 25 and 37, does that make 62? Yeah, it does. So that's okay. So 37, and don't forget to plus 1, so it's 38. So now if I know that there are 38 of these lines, then the answer is 100 minus 38, I think. So then the answer is equal to 100 minus 38, and that's equal to 62, I think. I subtracted the number from 100 by, I guess, subtracting it from 100. What I usually do is I take the tens digit, I subtract the tens digit from 9 because I saw that the ones digit is going to have a borrowing. So 9 minus 3 made 6, and then 10 minus 8 made 2. So I think the answer is 62. And I see that from the chat people are saying yay. So that means that must be the answer. Okay, so that's this question. That was a nice question. At first I wasn't sure if it would be crazy, because actually you can do all kinds of weird things here with subsets. But it turns out when you focus on saying no two add up to something, then you can just pair them up, and you can only take one of each one. Okay, let's do more questions. For those of you who have been at this live stream before, you know that what usually happens when I say, let's take more questions, is I reach over here and I pick up a cup of water. Except that over here I realized that I haven't done live streams in a while and all I've got is a mouse. So what I'm going to do is I'm going to run over there and get my cup of water, and I'll be right back and we'll do another question. One moment, please. The water's back. All right, more questions. Drinks mouse doesn't work very well. Okay. Whoa. Okay, winter rain has a problem, a question which looks interesting. It could be a horrible question in the sense that we could get stuck here for a while, but I'm just curious what the answer is. Winter rain says, if 97 divided by 16 is equal to W plus 1 over X plus 1 over Y, where W, X, and Y are integers, what are they? So it's equal to this. Let's just say it is this, and W, X, and Y are integers. What are they? Oh, I like this question. At first I thought it could be very problematic. I thought we might have to do guessing and checking. But I have a guess that this thing is related to a notion of continued fractions. A continued fraction is where you have something plus 1 over something plus 1 over something, and it just keeps going. If you want to figure out how to do these continued fractions, oftentimes what you do is you go and first take the biggest integer you can out first. By the way, there's no guarantee that this will work. No guarantee that that's how you would get W, X, and Y. But, oh, is there a typo? Well, hopefully there's no typo. Let's see. But what I'm going to do is I'm going to go ahead and try to take out the biggest whole number that I can. You see, 97 over 16. What's that? Well, 97 over 16 is sort of like 96 over 16. Whoa! Oh, 97 over 19. Okay, I see that people are saying that we should change the problem, because 97 over 16 I already see is like 6 and 1/16. So you want 97 over 19, okay? So now if I do 97 over 19, I think of 95. So for example, I know that 97, yeah, let's do it that way. 97 over 19 is equal to 95 over 19 plus 2 over 19. Okay, but why did I do that? I did that because 95 over 19 is just 5. Okay, so this is equal to 5 plus 2 over 19. Oh no, this is not going to be good. Can I actually write 2 over 19 in that way? Oh, I can. I'm excited. This is good. Okay, I can. So 2 over 19 ends up being 5 plus 1 divided by 19 over 2. Now, can anyone write 19 over 2 as x plus 1 over y? Well, you can, because 19 is odd. And so, 19 is odd, therefore it's going to be something and a half. A half is a half. A is 1, right? So I can do this. This is equal to 5 plus 1 over, it's 9 and a half. 9 and a half. Hooray, it worked. So I found out w, x, and y. W is 5, x is 9, and y is 2. And we're good. And the question, I think, asked what's the sum of w plus x plus y, but I just found all of them. Okay, thanks for the question. That was nice. And this idea of continued fractions is in fact something that you can do. If you go and take any old number, you can often actually write the number as something plus 1 over something plus 1 over something. And the way you make the continued fraction is that you actually go and always grab the biggest thing you have first. Actually, let's have some fun. Let's make another continued fraction. Somebody give me something over something. What's your favorite numbers? Give me like something over something. I want like an integer, a whole number over a whole number. And we'll see that you can do this with just about anything. 69 over 42. Here we go. 69 over 42. First, I want to simplify them and think, is there any way that I could divide by a common factor? 42, ooh, I can. Because 42 is 6 times 7, and there's a multiple of 3 here. So we should go and knock out some factors of 3, right? So let's first get rid of factors of 3. I get 23 over, what is this, 14? Okay. Now what do? You go and say 23 over 14 is like 1 and something, right? It's 1 and 8/14. Did I do that wrong? I think I did that wrong. 9/14. Now is that right? 14 plus 9. Yeah, 23. Do you know how I knew it couldn't be 1 plus 8 over 14? It's because 8 over 14 would have simplified. And because they're both even. So it's like, it would be bad if that one simplifies and this one doesn't. You see, there's something here. It's actually the heart of what's called the Euclidean algorithm. But if you ever have something which is in simplest form already, and you write it as a mixed number, you can't further simplify that. That's a cool fact, and it has to do with what's called the greatest common divisor. But let's keep going. Yeah, what's this? We're actually doing what's called the Euclidean algorithm anyway. But let's keep going. So I want to do 1 plus 1 over something. All right, well, we will. It's 1 plus 1 over 14 over 9. Okay. 1 plus 1 over 14 over 9. Well, I have to break 14 over 9 into a mixed number now. It's 1 plus 1 over 1 plus 1 over 1 plus 5 over 9. Is that okay? Hopefully I didn't make a mistake. I think that's okay. Now we keep going. Let's go and flip the 5 over 9. I'll use a different color so it's easier to read. 1 plus 1 over 1 plus 1 over 9 over 5. Oh my gosh, this is going to take forever. This is 1 plus 1 over 1 plus 1 over 1 plus 4 over 5. Okay, we're almost done. The reason we're almost done is because I see what's going to happen when you flip the 4 over 5. So that makes me happy. We're about to finish. Okay? So if I continue, I have to do a 1 over 5 over 4. So let's keep going. This is equal to 1 plus 1 over 1 plus 1 over 1 plus 1 over 5 over 4. And finally, let's go and write the whole thing. So we have 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 4. Okay, and it ended. Actually, whenever you start with a rational number, which is like a fraction, which is a whole number over a whole number, you can always do this, and eventually it stops. Now, the reason why eventually it stops is because of what's called the Euclidean algorithm. Actually, if you take a number theory course, or if you learned number theory with me before, we talked about how you can find the greatest common factor between two numbers by subtracting the smaller one from the bigger one. And that's actually what you're doing here. And so the fact that eventually you get to 1 over something is directly the same fact as if you start with two numbers which are relatively prime to begin with, meaning no common factor. If you have no common factor, you can do this and do this and do this, and at the end you'll have a 1 over something. So that's a cool fact. Okay, more questions. And now I have water. Hello. Oh, I see. Winter Rain gave the correction about the 19. Okay. Codecrafts has a puzzle. So Codecrafts wants us to do this puzzle. It says add one line. You get to add one line to 9 plus 6 plus 3 plus 5 equals 17. And you get to add one line. And that's supposed to make this true, but you can't just like add the line here. That's cheating. You cannot make it a not equal to. So the question is add one line. How do you add one line? And Codecraft said you cannot make it not equals to. So let's take a look. So if I wanted to just add this together, this is 15. Ooh, it's 23. Oh no. 23. That's interesting. Now 23 happens to be exactly 6 too big. That makes me wish that I could do a subtraction. could I subtract the 3? Would that work? You know, because I got an answer of 23, which is too big by 6. And whenever you flip the sign of a number, you lose double of it. So I sort of would like to get rid of the, I'd like to do minus 3, right? I'd really like to minus 6. But if I can turn a plus 3 into a minus 3, that would work. How do you make the 6 negative? Right? So, I mean, to me, I'm not sure this is legal, though. You know, I would like to put a line here. But that's not usually how you do it, right? I'm not sure you can write it that way. So I'm not really sure if that's the answer CodeCrafts was thinking of. Because if I'm allowed to do that, then I think I got the answer, because then I have 17. Is there another way? Yeah, if we cross out the 6, I guess that's okay. Oh, CodeCrafts says that's correct. Thanks, CodeCrafts. So CodeCrafts is saying, you know, you want a minus sign. And, all right, I'll give this to you. I wonder if on a calculator that might actually work. I'm not actually sure how your calculators or computers work. But if you go to like Wolfram Alpha and you write plus minus 3, I wonder if that works. Strictly speaking, we actually want to have some parentheses here, and that would make it a bit better because people don't like to put like a plus sign and a minus sign right next to each other. But I'm actually quite curious. On the calculator, my gut feeling is even if there's no parentheses, it might actually work. Okay. Neat. Okay, well, I always like these kinds of puzzles. More questions. Syntax error, Gerald Tong got. I think it depends on what kind of calculator you have. Oh, I see that I've been asked Python or Java. Well, these days, I think I don't use... Oh, you know what? I've actually used both of them recently. I used Python when I was actually helping last night. As some of you know, I work on this app called Novid, which is trying to stop the world from having too much COVID. And so last night I was actually doing some programming on part of ours, which sends these early warnings of exposure to COVID. And so that's written in Python. So last night I was writing some Python. But maybe about 3 months ago, I was writing some part of our app where we were sensing distance between devices with ultrasound. And that was Java. So I used both of them. So to me, I think all the computer languages are interesting. Once you learn one, you can sort of figure out all of them. More questions. Oh, Daksh Gupta says C++ is best language for competitive programming. And last night I was also writing C++ because the way that our system works, in order to send enough notifications to people fast enough, we actually have a part of it that runs in C++ because that's the fastest. So we in fact have that language also, and that's an important part of what we do. More questions. Oh, okay. So I see a question that has some geometrical flavor. Let's find out. The problem is that a picture is worth 1,000 words, so I don't really know what the question is yet. I just see the words. But I'll read the words and we'll do the question at the same time. So this is by Xiaozhu Cheng, and it says, a square surrounds a circle with a radius of 10. Okay, so first I need to draw a circle. Hang on. Is that one okay? Sort of okay. So I've got a circle, and the circle has radius 10, okay? So the circle here has radius 10. And what's going on is that there is a square that's surrounding this circle. Okay, square. How do you draw a square? Drawing circles are easier than drawing squares, you know. How am I going to draw a square? I guess I have to draw a square. That's how you draw a square. Oh no, how can I draw a good square? Help. As you can see, circles are fundamental objects. What a lousy square. Oh no. As you can see, I much prefer to draw circles. Maybe this is a square? Okay, let's pretend that's a square. It's kind of tilted. You're right. It is tilted, and the reason why, see now I'm telling you, this is why circles are better. Nobody was complaining that my circle was tilted. Wasn't my circle tilted too? Don't you see? If you tell me that my square is tilted, my circle is also tilted. But that's why the circle's better. The circle's better because you can't tilt it. Oh, no, draw the square first is a very bad idea. The first lesson that I learned when I did these Math Olympiad contests when I was in high school is people told us, when you're drawing a diagram, always draw the circle first, because the circle is very, very hard to deal with. But if you draw the square first and then you got to draw a circle inside, it just won't work. But now you can see, right? That's why circles are just so much better, because when you draw squares, they get tilted. And this is actually why circles are more fundamental than squares in geometry. Because in geometry, a circle is just what you have if you have a center and all the points at equal distance. It's more fundamental. All right, but I was supposed to do a question here. The question said there's another square inside it. Okay, so let's draw another square inside it. Oh no, I've got to draw another square? Well, at least it didn't say how to do it. It's just inside the circle somehow. Oh, here's a tip. Do you know how to draw a square inside a circle? The tip is, don't just start drawing a square. No. Instead, what you want is you want to pick out the points and then connect the dots. And how do I pick out the points? I make the points so that they're, oh yeah, you can see I'm thinking geometrically. I made each point by imagining a line that went from the center to the corner, and that's how I picked the point. And now once you got that, now you connect the dots. If you just tried to draw a square, by the time you were done, it wouldn't look like a square. But once there are dots, oh, it's so easy. Boom. Clearly, this class is called Ask to Draw Anything. What else do we do? What was the question? Where'd it go? Oh, what's the area inside the larger square but outside the smaller square? Okay, so the question is how much area is there inside the larger square but outside the smaller square? So the question is, let's use one of these highlighters. This might actually work. Yes, this sort of works. The question is, how much area is that? Okay, actually we probably spent more time drawing the picture than doing the problem. But how much area is that? Oh, you never see that tool. Yeah. So this is like some highlighter tool. I learned that it existed while I was teaching the Math Olympiad class. So anyway, we're just going around. And so the question is, how much area is that? Okay. So let's see. Well, we first need to use the fact that we have the radius is 10. So we can find out the area of the big square, right? The area of the big square is 20, 20, 20, 20. It's 20 squared. So the whole thing is 20. Oh no, I'm still in the highlighter tool. Switch up. Okay, so it's 20 by 20. And so the big square, I guess I should have used green for the whole thing, but the big square is 20 squared. And then I have to subtract the area of the small square inside. Now, the small square inside, we also have the radius of 10, so I guess I should run the 10 this way. If that's 10, then the whole diagonal is 20. That's how we think of these things. So if I do this guy, this is 20. Now, if this is 20, what's the area of the square? Well, I can find the side length. This is a 45, 45, 90 degree right triangle. So, by the way, there's a nicer way to do this, but I'm just going to say this one first. So I've got this 45, 45, 90 right triangle. So if I had that, then I just need to know that each of these two sides is like this guy divided by the square root of 2. The ratio is 1, 1, and the square root of 2. And so I could figure out what this is by just dividing by the square root of 2. And so this guy here is 20 divided by the square root of 2. And it's a square, so I can say 20 divided by the square root of 2 squared. But I want to emphasize the math here always works out the same way. All right, and temp ID is right. That's actually what I want to do next. But let's just do this quickly. This is going to be equal to 20 squared minus 20 squared over 2. Oh, that's really interesting. That means that the answer is exactly 1/2 of 20 squared. So what we're saying here is that exactly half the area is shaded. Could we believe that? Yes, there is a way to believe that. The way you'd believe that is, in fact, you just use a different way of drawing that inside square. Let's rotate the inside square by 45 degrees. So to do that, oh, do I have to erase everything? Here's what we'll do. We'll do some erasing, okay, and that will make it not as pretty as it was before. But if we do some erasing, what do we get? Erase, 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 erase this, erase this, erase the highlighting. I'm scared to actually erase the dots because I'll probably erase the circle. But now let's do a tilted square. Oh, we can connect those 4 points, right? It's like a diamond. So let's go and find the points. Here, 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 and here. And now we connect the dots. All right. Now, once we do this, it's extremely clear what's going on. Because if we want to know what's the area in between, oh, now this highlighter is going to be tough because I need to sort of do weird triangles. You get the idea. So I need those things, right? But if you look at those things, then that's clearly half of the area. The reason it's clearly half of the area is I can imagine if I cut that too, and if I cut this like so, then each of those triangles has a triangle over there. So there's a 1-to-1 correspondence. It's like you took the inside and pulled it out. So that's why it's half. So the answer is half of 20 squared, and half of 20 squared is half of 400, which is 200. And so that's the answer. The answer is the area in between is 200. Okay. There is green haze just outside Po-Shen Loh's hair. That's right. That's because, as some of you may know, this happens to be on a green screen. And since it's a green screen, sometimes if I move too fast, there's like a green haze, like this. Okay, more questions. So I see there's a question about explaining linear combinations. That one will be a bit too advanced for the audience that we're targeting here. We're trying to be understandable to people who are learning algebra or geometry. That one you'll need to go and check out linear algebra, which is really interesting too. But that's a different level from here. Okay. Oh no, now everyone wants me to wear the green shirt too. Yes, the green has been here since the first live streams, that's right. Oh, I see a sequence. Jack Y, 1, 5, 10, 25, question mark. I don't know. 1, 5, 10, 25, question mark. I don't know what's next. Oh my gosh, you're right. These are like US coins, right? Is that the idea? These are coins. There's a penny, there's a nickel, there's a dime, there's a 25 cent, which is a quarter, and there's a US coin, which is a 50. I think that's a legitimate answer. Is that the answer? Thanks to the group here for suggesting that, but maybe that is the answer. This is United States coins. You know, it's really interesting that United States coins have a 1, 5, 10, 25. 25. Why did we go from 10 to 25? Do you know that there are other countries where they don't have a 25? So I spent a year living in the United Kingdom, and that one, they don't have a 25 cent. Is anyone here from the United Kingdom? I actually don't know. Is there anyone here who's from the UK? Anyone live in England before? I believe it's a 20p coin. So I think it's 20. In India, 20. Okay, right. So in the UK and in India, it's 20. So it goes 1, 5, 10, 20, and then 50. But the problem is that somehow there's no nice way to do this, right? Because the thing is, you generally have 100, right? If you have 100, then you're going to have 50. And if that's like half of 100, that makes sense. But then the question is, between the 50 and the 10, what are you going to do? Are you going to divide by 2, or are you going to divide by, well, nothing? You can't divide by 2. It's like either you divide by 2 here, or you times by 2 from the 10 up. So you have a choice of either 20 or 25. And that's just because we happen to be in a base 10 metric type money system. Actually, I don't even know how the British used to do it. I believe they used to have something called pounds, shillings, and pence. But that was before I lived there, so I don't even know how they did it. All I know is that must have been even more complicated. Okay, more questions. Yes, Temp ID says shillings or something. I don't know enough about shillings. Oh, this is neat. Let's try this. So Minco X says, Minco says X, a radio beacon is located at -5, 3. I guess I need to go and draw some axes now. So we're going to have axes. Hopefully that's okay. And we have minus 5, 3 is one radio beacon. Where is minus 5, 3? I guess you go 5 this way. And 3. Oh, it goes up. In that case, I'm going to change where I drew the minus 5. Let's put it here. And we'll put a dot. Okay. As you can see, I care very much about drawing diagrams. I think that if you have a good diagram, it's easier to see how to do the problem. Oh, what's a radio beacon? Asks TempID. It's like something that makes radio waves. So it's like a broadcasting point. And another one's at 9, 13. So if I want to be sort of to scale, if this guy is 5, then, okay, I should go 5. And then that would be 10. And so maybe not quite as far. Maybe that's 9-ish. Let's call that 9. And it's at 9, 13. Oh my goodness, 13 is way up there. Okay, how do I do that? Maybe this is 13. Let's pretend this is sort of right. So if I've got these two radio beacons, it says that there is, a navigator's equipment tells her that the line joining her position to the first radio beacon has a slope of minus 1/6. Minus 1/6. How could I actually draw that? Well, I would need to draw it where it went down 1 every time it went across by 6. So 6 would probably be around here. And I like connecting the dots. So there's this line here, which has a slope of minus 1/6. And there's also another one where there's the line joining to the second beacon has a slope of 6. Now, if one slope is minus 1/6, and the other one has a slope of 6, there's a nice geometrical thing to this. The geometry is that then they are perpendicular. So if you multiply the slopes and you get minus 1, then they're perpendicular. That's an algebra fact, very useful. Then I can just draw a perpendicular line. Okay, and let's say that did that look perpendicular? Not really. Let's try again. Sort of. And this is slope 6. And the question is, where is the intersection point? Okay, where is I see some people have been here with my other live stream. Someone said the word apples. But anyway, so we want to know where this is. Okay, I could do this by what's called coordinate bash. I can go and write down an equation of a line that goes through this. And I can write down an equation of a line that goes through that. I'll even start doing that, and we'll see how painful it is. What is the equation of the line that goes through this with slope of minus 1/6? You know what? I want to have 2 different colors now, because that will be easier for me to say which is which. Okay, so now let's use yellow. What is the equation of this line? The equation of this line, there's some point slope form which is useful. It's that I can just think of y minus the 3 divided by x minus the minus 5 is supposed to be minus 1/6. Does everyone agree? That's the equation of the yellow line, because I will take the difference in y, the change in y, remember from this like minus 5, 3, right? The change in y over the change in x, okay? So then, if that's the case, I can multiply across and I can get an equation. The equation is y minus 3 is equal to minus 1/6 of x plus 5. That's the equation of this line. And this is called the point slope form. If you memorize it, you can memorize it. But I usually just think of this, and I get it whenever I need to. How about this this purple diagonal? The purple diagonal, I can do the same thing. And if I save one step, the purple diagonal will give me y minus 13 is equal to 6 times x minus 9. I do want to emphasize, a lot of people memorize these formulas, and it's very easy to forget, like, was it plus or was it minus? Was it the slope or was it the apples? Like, do I divide or do I times? It's too hard to remember all that stuff. It's much easier just to be like, hey, what does it mean? It means the slope, okay? And as some of you who saw another one of my live streams before, I just joked, we could have come up with a different notion called EPOLS, E-P-O-L-S, and just done everything upside down. and you'd still get legit equations. But now, who wants to solve these two equations? Not me. Let me show you another way. Let's just use geometry. So I've got this point here, okay, and I'm using the fact that I have some perpendicularity. I think I can draw... Wait, am I right? Now I'm not sure it's so nice anymore. I was like, I think I can draw a square. Oh, can I? Or can't I? Okay, not so nice anymore. I was going to be like, gee, it's just going to be simple. Except that I don't know that this is going to be a 45-degree angle. I take that back. It's not nice anymore. Oh, drat. So I had been hoping that this would be something that's nice. But unfortunately, because you told me the slopes, that's not going to be good enough. So, okay, I was actually going to just pretend that this was a square and then just say like, okay, I'll go from the center and go here. But that's not going to be great because it doesn't have to be a square. It could actually be a rectangle. All right, solve equations time. I'm a little bit curious what the answer is. What's the best way to solve this system of equations? Well, what I'll do is I think I'll use the substitution method because y is so conveniently over here, right? So if I add 3 to this top equation, let's clean this off, plus 3. This is what you're usually used to seeing in the point slope form people might memorize. The minus 13, let's add 13 to both sides. Okay, well now, those are both y, so let's equate this. Let's figure out what the x is. All right, so if I want to figure out what the x is, they're equal to each other, so put it together. Yikes, disgusting. Okay, so I have minus 1/6 x plus 5 plus 3 is equal to 6 times x minus 9 plus 13. The first thing I'm going to do here is I'm going to, I don't like that fraction, I'm going to times up a 6, but first I'm going to minus the 3 from both sides so that I can get rid of the plus 3 and just have a 10 instead. So I have minus 1/6 x plus 5 is equal to 6 times x minus 9 plus 10. Running into my head. Okay, so if I've got this, now I times up a 6, so I get minus x minus 5. Let's shift the equal sign so it doesn't run into my body. This equal sign is usually supposed to be aligned there, but oh well. 6 times 6 is 36. Oh, these are terrible numbers. X minus 9 plus 60. But I promise you we're almost done. Because I've got a 36x and I've got an x, a minus x. So let's pull that over here. I've got a 37x. And what else do I have? So I have 36 times 9. What's 36 times 9? It's a big number. But I'm going to push everything over to this side, all those numbers to this side. So when I finally do that, it will be something like 36 times 9, that's a times sign, minus 60, minus 5. Is that okay? What I just did is I took the 36 times 9, that's a minus sign, so when I add, it goes there, minus a 60, and then there's a minus 5. All right, so what's 36 times 9? So it's sort of like 360, but minus a 36. Is that 324? I think it's 324. 324 is a nice number. It's stuck in my head. So that means I must have seen 324 before. 324 sounds a lot like a perfect square that I might have seen before. Is 36 times 9 a perfect square? Oh, it is. Look at that. 36 is 6 squared. 9 is 3 squared. So multiply, this is 18 squared. Of course, 18 squared is 324. So I have 324 minus a 60 minus a 5. 324 minus 60 minus 5. Okay, so 324 minus 60, that's nice. That's 264, I think. 264 minus a 5. 259? Oh no, really? 264 minus 5 is 259. I hope. Did I do that right? I could have done the subtraction wrong. I tend to do subtraction wrong all the time. Okay. Now, is it going to be 37 times anything? I hope it's a nice number. If it's going to be a nice number, if there will be any hope of a nice number, 7 times what ends in 9? Well, 7 times 7 is 49. Is there any hope that 37 times 7 is 259? Let's find out. 37 times 7, 49, 21. Oh my gosh, it works! So it's 259. Okay, so it works. So it's 259. So in that case, x is 7. Okay, so if x is 7, let's go figure it out. Which of these equations do you like better? I don't like fractions, so let's go over here. Oh no, I do like fractions. The reason I like fractions now is because I saw what would happen. 7 plus 5 is 12, right? So if I put a 7 there, I get 12. Minus 1/6 of 12 is minus 2. 3 minus 2 is 1, so y equals 1. And so now we know where this point is. This point here happens to be at 7, 1. And now I'm a little curious. Were these numbers cooked? So over here I have minus 5, 3. Over here I have 9, 13. Over here I have 7, 1. I'm a little curious what's in the middle. What's the midpoint? So the midpoint would be if I went and drew a straight line and just drew a midpoint in the middle. The way you get the midpoint is you average the x-coordinates and you average the y-coordinates. It's like the middle, right? So minus 5 and 9, that gives you average of minus 5 and 9. If I add them, I get 4. I have to divide by 2, so it's 2. And the average of 3 and 13, 3 plus 13 is 16. Divided by 2 is 8. Okay. Now, here's what I wanted to do. I was like, if that's 2, 8, what's going on over here? I'm a little bit curious what I do to go there and what I do to go here. I actually want to know, is this actually a legitimate square? So how would I do that? I guess I would be curious, if I want to go from this point over to there, what happens? So I go over by 7, and I go up by 5. So you go over 7, up 5. Oh, wow. These numbers were very carefully picked. I don't need to bash the distance formula, actually. Instead, I can draw something. So if I want to go from here to the center, I go over by 7, and I go up by 3. No, up by 5. Did that make sense? From minus 5 to 2, I go across by 7. And then if I go up by 5. Well, now, if I wanted to go from that center over to this corner, what do? I go down by 7 and over by 5. Down by 7 and over by 5. And if you can see, this piece and this piece, it's perpendicular, right? The slope of this guy is 5 over 7. The slope of this guy is minus 7 over 5. It's because I have these two same lengths, but now over there flipped, that I actually have that these two lines are perpendicular. So, in fact, what I've just found out is that this middle point is perpendicular here. This is a right angle right here. And so, in fact, this was actually the corner on a square. So, you see, when I look at this thing, this is why it was neat that at first I tried to draw the picture as carefully as possible. When I drew the picture, I said, it really looks like a square. It looks like all I have to do is find out what's that point there on a square. But then we found out, we could be unlucky. It could be like slightly off. And if it's slightly off, this would be a point on a rectangle. But at the end, when I worked out everything and I got whole numbers, I said, well, then, if there's a whole numbers, there's a decent chance that this happens to be actually the last point on a square. And it is. Okay, well, thank you very much for this question. This was kind of neat. I didn't expect it to work out so nicely. All right. Oh, I Like Things has asked, how do I enter those slopes into a graphing calculator? I'm not exactly sure what you mean, But I would say that if I look at a question like this, if I know the slope and if I know a point it goes through, I can make an equation. And the equation ends up being something like this: y equals something. In most of the standard graphing calculators, you just write the y equals, and then you take the something and you just type that into where you're supposed to graph something. So that would be the answer I'd give you. Okay, more questions. I Like Things has asked another question. I'm doing algebra and geometry at the same time. Got any tips for doing multiple fields at the same time? Welcome to Ask Math Anything, where the only thing we ever do is multiple fields at the same time. I mean, what you've just seen is a combination of both geometry and algebra at the same time right here. My general advice is that if you're able to learn on your own, especially this year, I know that some of you are taking classes at home now. Of course, there's school classes, but you take them at home. My advice is to use your time to go and explore. And if you go and explore, you can go and start thinking about both algebra and geometry at the same time. I learned that when I did the math contest stuff. When you go and play with math contest problems, you end up doing a lot of different types of math at the same time. And soon your brain doesn't really think of it as that's algebra, that's geometry. Puts them both together. Okay, more questions. Somebody asked me, what key switches do I have again? Are they MX Blues? Yes. So I have the MX Blues. I think that they are great. They make a wonderful clacky sound. These are like for a keyboard where you can type and it goes clack, clack, clack. Some of you may be able to hear that in the background on this live stream sounds like there's typewriters or sounds like there's keyboards. It's because there's a lot of people in our office who use that as well. And honestly, I find they're the most satisfying to type on. Okay, more questions. Winter Rain asks, do you think that humans are currently in a simulation? That is such a meta question. You see, if the answer was that I was in a simulation, then you are the simulation, and you've just asked me, am I in a simulation? That's a very, very strange idea, right? It's like somehow, if I was in a simulation, maybe the simulation is now asking me, am I in a simulation? My approach to all of these is, if I was in a simulation, I don't know what I could do about it anyway, but maybe I'm not. And if I'm not, let me go and try to do the most I can, assuming I'm not. Okay, more questions. More questions. Technical Hacker asks, what was the logic behind digital sum? I'm not entirely sure what you mean by digital sum, but I'm going to make a guess. Do you mean like sum of the digits? There's a rule about divisibility by 9, or finding the remainder when you divide by 9, which is based on taking a digital sum, which is the sum of all the digits of a number. And the basic idea behind that is it's because 10 has a remainder of 1 when I divide by 9. So if I had like 32, well, the 30 is 3 tens. Each of those tens has a remainder of 1 when I divide by 9. So I've got 3 extra remainder plus 2. So the remainder when you divide 32 by 9 is 3 plus 2. That was really fast, I know. I'd advise go and look at a number theory, very basic number theory type book or explanation, and you'll get a lot more about that. Okay. Ban all hackers. Oh, I should say there are also good hackers. I mean, with what we're doing with Novid, we're trying to make sure that we are making an app that's safe to use. So we even have a hacker on our team. And the hacker's job is to hack Novid, but to tell us what was hackable, and then we fix it. So hackers are really useful too. Okay. Oh no. Satya Memi says, there is a Novid 19? Really? Oh no, I didn't know other people are using our name. I should say that the name has been very helpful. I have never had to explain to anyone in the world what Novid is trying to do. They sort of get it right away. But Novid 19, I didn't know that. More questions. Oh, okay. Here's a question that looks like it could be a lot of work. Well, your question is, Ashvant Daniel, what is the value of 101 cubed minus 3 times 101 squared plus 3 times 101 minus 1? Let's do this in two ways. The first way is it's actually not that bad to multiply this thing out. Okay, let's multiply this out. What's 101 squared? Look, they're really nice. I just want to show you that the numbers are really nice. Don't worry, there's a better way. But 101 squared, if I want to multiply it by itself, it's nice. It's 101, don't worry about the 0, 01, look at that. It's 10201. How nice. And so that's the 101 squared. And what's 101 cubed? What's 101 cubed is you multiply it by another 101. 10201 times 101. The reason this is nice is you're just kind of shifting stuff over. 10201, shift over, 10201. Kind of mysteriously, I get a 1030301. 121, 1331. I've sort of seen these sequences before. But let's see what happens. So I put everything together. I need to go and take 1030301 minus 3 of these, which is 30603. Okay, subtraction time, very difficult. Actually, legitimately very difficult. What is this? Is it 9? Hopefully it's 9. As you can see, subtraction is very hard for me. What? This thing, 9. Okay, so 12 minus 6 is 6. Oh, I have to keep borrowing. What? What a crazy number. 9. Keep borrowing. 9. 9. Help, is it right? I hope this is right. So I've got 9999698. I hope I did that right. And now I need to add 303 and then minus 1. So let's add 303. 8 and 3 is 11. Okay. Ooh, carrying. Oh my gosh. Look at that. And now I'm minus 1. So when I do that, if I minus 1, the answer to the whole problem is 1,000,000. How could that be? Okay. So if it's 1,000,000, there's got to be a better way. And the reason there's a better way is because this is a nice form. Okay, so that's a nice form. So it turns out that if you take x minus 1, let's just say we had x, and you multiply it by itself, why not? That's easy. Well, I don't mean that's easy. I just mean you just do it. You take x times x is x squared. But then you have a minus x and another minus x. That's minus 2x. Okay. And then minus 1 times minus 1 is a plus 1. Fine. What if I did, just for fun, if I wanted to know what was x minus 1 cubed? Well, that would just be what I had before, x squared minus 2x plus 1 times x minus 1. Oh boy, how do I do this? Well, I guess I can actually try to expand this. So I will get how much from the x's. Let's do it this way. Equals. We'll have it from the x's, and we'll have it from the minus 1s. But I'll write it like this. From the x's, I get an x cubed minus 2x squared plus x. And from the 1s, I get plus x squared. No, minus, because it's minus 1. Minus x squared plus 2x minus 1. All right, that's what came from the minus 1. And look what happens. So what ends up happening is I just get x cubed minus 3x squared plus 3x minus 1. Okay, now this pattern, by the way, is also what appeared here. This actually always happens. It's called the Binomial Theorem. If you cube something, you get coefficients like 1, 3, 3, 1. And the minus signs that are alternating is because of the minus 1 over there. But once you see this, hey, can someone tell me what x I should put in? What x should I put in? If I want this purple to be this white up there, I should just do it where x equals 101. Thank you very much. So if I put 101, if x equals 101, let's do it here. Let me just write up here. This is from the x equals 101. So if x equals 101, then all I have to do is 101 minus 1, whole thing cubed. That's easy. 101 minus 1 is 100. 100 cubed, boom, we got it. And that's all it is. So that's why when I saw this question, I was like, aha, I think this is a nice question. We can do it really quickly if we happen to know this binomial theorem. But even if you don't know it, we can look at some neat patterns about what happens when you square these numbers. And this is just showing how this 1331 just keeps showing up here, here, and there. Cool. Okay. Oh no, we're at 5. So unfortunately, that finished the live stream for today. I hope that you enjoyed today's Ask Math Anything. I definitely got to do some interesting questions, thanks to you who asked them. We're going to have another one next week at the same time. We're just going to keep doing these on Fridays at this time. So see you all next week. Have a great week. Have a great weekend. Bye-bye.